Good morning, and welcome to the joint web seminar on Industrial 5G from 5G ACIA with Opc Foundation. And I'm Afifa Serran from Stockholm, working at Ericsson and the General Vice Chair of 5G ACIA. I'll be moderating this session for the next 2 hours. You will hear actually from different speakers from the both audience. And now let me share with you the agenda of this web seminar. After a short opening by both the leaders of 5G ACIA and Opc Foundation, the channel chair of 5G ACIA, Andreas Miller, will basically talk, briefly, and this will be followed by a message by Stefan Hoppe, the president of Opc Foundation. Then later on, you will hear technical talks, starting by from Opc Foundation about the use cases, the progress in the Opc unified architecture, and more in particular, the communication aspects. Then afterward, from Ate on the 5G architecture and integration with industrial networks. And will be followed by recent development on Opc Ua with 5G, and Shuli Ann, where she will summarize the work, what we have done actually within 5G ACIA. And after that, you will see a live demo from Frankfurt, and this live demo will be conducted from both sides, Opc Foundation, Peter Lutz, and then from 5G ACIA, it will be Joseph Eischinger from Huawei, as well Alexander Seeger from Siemens. And we will have approximately 25 minutes to answer your questions. So this is a summary basically of what will happen for the next 2 hours. And now it's my pleasure to hand over to Dr. Andreas Miller, who is the General Chair of 5G ACIA.
All right, thank you very much, Afif, and also a very warm welcome here from my side. So my name is Andreas Miller, as Afif has mentioned. In my day job, I'm working for Bosch, but I have the pleasure to be here today in my role as the General Chair of 5G ACIA. And it's really nice to see such a strong interest in 5G manufacturing and also Opc Ua. So 5G manufacturing certainly still is one of the hottest topics in the 5G arena. Maybe some things take a bit longer than we have originally expected, but I'm still very confident that it's just a matter of time until really many factories worldwide will really be operated based on 5G. So also looking back at the achievements of 5G ACIA already, so we have established 5G ACIA a bit more than 4 years ago. So this year at the Hannover Trade Show, we have celebrated our 4th anniversary. And we started off with 26 founding members, and as of today, we are 94 members. So that's really an impressive and very nice growth that we've experienced here. But it's not just counting members, it's basically more the impact that really matters at the end. And I think also here we have done a lot of work on many relevant topics, thinking about use cases and requirements, bringing them to standardization of HPP, making sure that the right features are supported, the right capabilities are provided by 5G. And I think if you look at the standards, especially what is coming with VD 16 and VD 17, so then there's a lot of it included that really matters and makes a difference to the industrial domain. So I'm thinking about the low latency, the high reliability, TSN support, and things like this. But it's not just the KPIs, the key performance indicators that matters. It's also then things like non-public networks that are very important to the manufacturing industry. And also here we have done really quite some work over the last couple of years. But having just 5G industrial grade alone is not enough, because 5G will never be the solution for any connectivity problem in a factory, right? It's always a heterogeneous setup with different technologies coming together. And what really matters a lot here is what we call shop floor integration. So that we think about how can we integrate 5G with other technologies that already are in use today in a factory or that may come up in future. And this includes things like time-sensitive networking, TSN. It includes things like Opc Ua, concepts like digital twinning, and so on. So at the end of the day, all the different building blocks have to seamlessly fit together. So therefore, the shop floor integration in general is a big topic for us. What is key here is a collaboration between different stakeholders, because different organizations, initiatives are dealing with different topics. And that's why we have established really a very strong partner network in 5G ACIA over the last couple of years. And we are very happy and proud to also have this good partnership with the Opc Foundation, especially looking at how to combine Opc Ua and also Opc Ua FX with 5G. And we've done quite a number of activities already in this respect. The webinar today is one component of it. And I hope that this gives everybody a good overview of what it's about, why it matters, and also where we currently are. And yeah, I hope you all enjoy the webinar. And of course, if you have an interest to learn more about the activities of 5G ACIA, but certainly also Opc Foundation, so please feel free to get back to us at any point in time. So we'd be happy to provide more information, and also maybe to invite you as a guest to one of our next meetings. So we will just now in the transition of going back to face-to-face plenary meetings at least. And the next one is scheduled in September in San Diego. So that's would be a great opportunity then to get in closer touch with us. So that's some short remarks from my side. So really thanks again for joining. Wish you all a nice webinar. Thanks to all the presenters already for taking the time. And with that, I give it back to Afif, and then I think we will also hear a few words from Stefan Hoppe from the Opc.
Yeah, thank you, Andreas. And let's directly basically hear what Stefan will tell us. He recorded 2 minutes message. Basically, he was not able to, unfortunately, to be live today.
The 5G, ACIA and the Opc Foundation are partnering to cooperate on combining technologies, which is Opc Ua and the 5G. We believe that combining both technologies is a win-win for the industry, enabling a bigger market growing in new adoption into new applications. Just 5G is not enough. It's a fantastic transport layer enabling new opportunities, but you need standardized, harmonized information on top with integrated security scaling, and this is what Opc Foundation is delivering with Opc Ua. We integrate 5G as seamless as possible into our Opc Ua stack, that it's extreme easily and completely integrated as another transport layer for Opc Ua scaling from field to cloud and back. The webinar, what we are doing to educate and explain the technology, explain when the market takes off. You get dedicated inserts from experts explaining both the Opc Ua FLC initiative, extending Opc Ua with deterministic, with safety, with motion, but also with the 5G characteristics. And both of that is an important strategy and technology for the future, which is already available and ready. If you see the demo, what the Opc Foundation did together with Siemens and others, we are running Opc Ua safety over 5G. It's up and running. The spec will be released this week. So it's up to you. We are ready.
Great, great. So let's move on into the first technical presentation. And the two speakers will be Peter Lutz, who's director of FLX of Opc Foundation, and Alexander Ziegler from Siemens. And will be Opc Ua, basically unified architecture, and Opc unified architecture FX with industrial use cases and 5G. So I will hand over to you, Peter.
Thank you, Afif. All right, so good morning to everyone. And it's a pleasure for me to, first of all, talk about Opc Ua and the extensions we do for the field level, named UAFX, and talk about the different use cases, especially looking at the combination of Opc Ua and 5G. So let me first quickly introduce the Opc Foundation. The Opc Foundation is a non-profit organization headquartered in the US. And this organization takes care of the Opc Ua technology, which is an IEC standard. You see here the number IEC 62541. The membership is currently with 875 members all over the world. And if you look at the companies represented in the board of directors, you see that we have a good mixture of automation companies and IT companies. This is already giving a good indication that the technology, Opc Ua, is actually important also because of the IT-OT convergence, sharing information from the field to the cloud and back. Opc Ua is understood as a completely open technology, specs openly available. We have open source projects. We have a certification program in place and use for the further development, also probably one of the most modern IPR policies in the industry. Now, looking at the Opc Ua technology itself, we need to emphasize that even a lot of people still believe Opc Ua is a protocol. We have to emphasize it's not a protocol, or we would say it's more than a protocol. It's like, we call it an industrial framework with different elements to ensure industrial interoperability. And on this slide, you see the three, I believe, most important elements in this framework. First, we have services and mechanisms to support interoperability, cross-vendor, cross-platform, operating system independent, scalable, and what we call a service-oriented architecture. There is an extremely broad adoption worldwide with all the key manufacturers providing products today. An important element from the very beginning was the included or integrated built-in security with different mechanisms that we provide. So you can select the security features that are relevant, like auditing, authentication, encryption. And in the middle, you see now probably the element that has caused maybe the broad acceptance, especially when we talk about the industrial Internet of Things and Industry 4.0, because this is about the information modeling, where Opc Ua is providing an extremely flexible and powerful modeling mechanism where you can model compact devices, complex devices, complete machines, or even a complete factory or a plant. And this is key because we have to ensure we have a common language, we have shared semantics when exchanging information. And especially with information modeling, we have more than 50, maybe in the meantime, more than 60 initiatives and corporations to do semantics in information models for different industries and verticals. Now, the overall vision of the Opc Foundation is, as Stefan already mentioned in his welcome, that we have Opc Ua as a fully scalable solution, consistent, unified, standardized communication solution, scaling from the field to the cloud and vice versa. So we have an initiative which is making sure we have the cloud connectivity supported with all the key cloud providers supporting that solution, like Microsoft, Google Cloud, AWS. And we have a dedicated initiative which takes care of bringing Opc Ua down to the field level. And this is where I want to give in the following more details what use cases we are talking about. But as you see from the graphic, the key is we want to convert the more hierarchical structures in automation, well known as the automation pyramid, to a much more flexible information network where you make available information directly at the source, and you can have then different clients or users taking that information to the edge or even to the cloud. Now, we use a more abstract interaction model, what we call it, in order to make sure we cover the different use cases in a more, let's say, abstract point of view. So we talk about controller, device, and compute interactions. And the idea is to have this all done with Opc Ua, with different mappings to underlying protocols and with the different semantics. And the solution certainly needs to cover all the different verticals, especially in our case of field level communications, factory, as well as process automation. Looking at the use cases, Opc Ua today covers already many different ones. Some examples listed here with the numbers 1 to 4. So IT/OT communication, cloud integration, secure remote access, local OT communication. And now with our field level communications initiative, we are extending the Opc Ua framework to cover additional use cases in the field level. And this is on the one hand side, the use case controller to controller, number 5 here, and then the use case controller to field device, which is then also including use cases like motion control, decentralized remote IOs, or instrumentation. And we certainly have to ensure we support real-time data exchange and also support functional safety. And these elements are all part of the extensions we name Opc Ua FX. We are now also looking, and this is part of the webinar today, how we can integrate wireless connectivity, especially 5G. This is why you see also the dotted line extending now the work we do in UAFX to support the integration of 5G. One of the key elements in the overall strategy and, let's say, structure is TSN. So this is on the one hand side because we need to support deterministic transport using standard Ethernet. So Ethernet TSN is the technology we are clearly committed, and especially we are closely committed and aligning with the ACIA 6802, which makes sure that we have not different flavors of TSN, but rely on a common TSN network infrastructure. So we get away from all these different field bus flavors and different and incompatible real-time Ethernet solutions. And TSN is also helping with the IT/OT convergence. As I said, this is also one of the key goals of Opc Ua. Now, looking a little bit more at the technical structure and architecture, let's have a look how this all is put together. Opc Ua plus extensions for field exchange and also the mappings to different underlying networks and physical layers. So first of all, the solution we are creating is based on existing Opc Ua technology. This is all the dark blue elements you see here, built-in security, client server, pub sub, the modeling. And we are then adding specific models for automation components and the different device types we find in the field level. Certainly, it's possible to add existing or future companion models that are developed out of different corporations, and vendors certainly have the possibility to do specific extensions on top. Now, important for our webinar today is the look now how this fits into the different communication standards. And this is where we come to use case specific mappings of the middleware of the framework of Opc Ua to underlying protocols and physical layers. And this is then certainly including all the different flavors like Ethernet, Ethernet TSN, the advanced physical layer, extremely important for the process industry. And this is also where we make sure 5G is well integrated and smoothly integrated. You see on the left-hand side that all the dark blue and yellow boxes are core Opc Ua specifications. And in the yellow color, you see what additions UAFX is developing for the framework so that this all fits together. All right, and with this, I'm now handing over to Alexander, who is talking a little bit more about specific use cases where we combine Opc Ua with 5G. Alexander.
Okay, so I hope you can see my video. Okay, yeah. Okay, yeah, let's talk about the different QoS requirements. Before, let me just introduce myself. I'm from Siemens, Germany, and I'm active in the Opc Ua Foundation and covering the topics QoS integration. So I'm more focused on the communication part of the Opc Ua layered stack architecture. And if you look at this figure, we saw that before in a different slide from Peter. Here we are emphasizing the relations to QoS needs and requirements in the different areas where OPC is used. So we see, for example, in the cloud area, we need a reliable streaming of data and events. And in the shop floor for C2C, D2D communication, we expect cyclic process data exchange. And of course, and this is the focus for today, we will need reliable, ultra reliable, low latency communication for wireless communication between robots, for instance. And that's something we like to work on with 5G ACIA to specify the requirements for that. Here's one use case example where we see two collaborating robots, one mobile and one stationary on the right side, which need to collaborate. And for that, of course, we need a wireless connection. And in combination with safety, we have additional requirements, not only mobility, but also the requirement of a reliable and low latency communication. And why is that? So OPC safety is, as Peter mentioned before, functional safety, and functional safety needs to make sure that any failure in your device will not lead to human or physical damage in your system. So we have a layer protecting your application and from that failures, and to make that work and to allow the safe interaction between these robots, this layer exchanges messages. Maybe you can go on the next slide. Is exchanging messages between the two robots. So the yellow part here shows the Opc Ua safety part, which needs to send out cyclically time-critical safety messages, which are then received by the other side. There is a kind of watchdog, which is looking at the incoming frames, and if some frames are missing, that signals the safety layer that there's something wrong. Maybe there's a failure on the other side, and the system then goes into the fail-safe mode, so in full stop. And of course, I do not want to have that because of a bad communication relation, but only if there's a real error in the system. And that means for wireless communication, we really need a kind of guaranteed bandwidth and a reliable connection. And that's even more important than the bounded latency we also need, because bounded latency then guarantees us that these messages can be sent out quickly and exchanged quickly. And the more quickly you can send out this safety message, the more efficient and the more performant you can create your safety application, because then you can limit the safety space of your robots and make your and set up your system in a more cost-efficient way, and even make it work faster and smoother. So this is important, and for in the sense of wireless communication. And we will have a deeper look on that integration aspects. You can see in the lower parts the green and pink boxes here in the one of the next presentation slots. Okay, thank you.
Okay, fantastic. So basically, ahead of time, thank you, Alexander. And let's move on basically to the next presenter. And this will be more from 5G. It will be general presentation about 5G architecture by Ati Lansilami, who is the Working Group 3 Vice Chair of 5G ACIA. He works at Nokia and he's based in Helsinki. So it's my pleasure to hand over to Ati.
Thank you very much, Afif, and warm welcome everyone also from my side. So as said, I'm representing Nokia and come live today from Espoo. My colleague Kurt Esikman from Ericsson is the chair of the working group, and he will be making the presentation in the afternoon. Yes, so I will be giving today the kind of higher level architecture presentation of 5G. There will be more about the OPC integration later in the session. This will be a sort of a layered presentation. I start with the use cases, just a little bit about them, going on to the non-public networks, which is kind of the key form of appliance for 5G in the industrial vertical. Then I talk a little bit about the ways the 5G system offers itself to the application layer. We call that the exposure functionality. And finally, a little bit more about the integration of the 5G into the industrial networks. And I'm basing the presentation on material coming from various 5G ACIA documents. And these white papers, they're all available in 5gacia.org. So while this is a very short presentation, I invite all of you to come on to the website and download the white papers and learn more about the subjects. Okay, so about the use cases and architecture. Well, on the left, you see the triangle that represents the kind of three corners of 5G development and the area within which 5G serves the needs of different verticals. And on the right, you see the main use case categories that have been, for example, studied in 5G ACIA and contributed to 3GPP. And as we can see, they all sort of land on the right part of the triangle, but within the boundaries. So the point here is that 5G was designed early on to support all the industrial use cases, and these capabilities are available in the standards today. Now, 5G architecture, we could talk a lot about the intricacies of 5G architecture, but for the use of industrial applications, for the use of industrial players, we more or less just want to keep it to a very simple level. We have the device and then the sort of fixed part. And the fixed part, it divides into the radio access network and core network part. But more or less, this is sort of like a black box. You don't, as a user of a 5G network, you don't need to worry about these things, even if you're the owner and operator of it. And the main point is that the 5G offers the communication capabilities via the UE to the network side or between the different UEs, and there could be a network of industrial applications even behind the UE. So it's a very flexible concept, and this is basically all you need to know from 5G architecture from the OT perspective. Now, then moving on to the capabilities and services that 5G provides. One of the concepts that you often hear is the non-public networks. which is the private network. And 5G, it's a cellular communication technology. So an inherent feature in it is that the radio coverage and capabilities are very well controlled, and the system tries to assure and maintain the level of agreed communication capabilities to the extent possible. So we have concepts of controlled handovers where devices move between radio access points without any interference to the communication. So that's the sort of basic concept in 5G and any cellular systems. What is and here in the center I have these NBN deployment scenarios that work with the cellular operators, telco operators. This concept is well known. We have seen it with the previous generations, and sort of what is coming out as a standard version first time in 5G is this standalone non-public networks, the private network, which means that you can build a 5G network inside your facility and operate it on your own without any connection to other networks if you so wish. And 5G can be flexibly used in this way. It can be used using different spectrum licensing models. Spectrum is available for this type of standalone NBN operation in many jurisdictions, and of course the operator provided options are very well available as well. Now, considering the case that one is operating their own network, you may think, as I was saying, that this system very well handles all the radio connectivity aspects, and how difficult is it to maintain such a network? Well, what I can say is that these systems come with very sophisticated automated network operation and management systems. So it is not a blocking point for anyone wanting to apply or install a private 5G network to their facility. And of course, with the sort of 5G in general, the new thing for 5G is that we have put in support for those industrial features, communication features that are very important for the industrial domain, such as native Ethernet and TSN, which then bases on this ultra reliable low latency communication, which takes me to the next slide, which is basically about that. So a key requirement for 5G in industrial domain is the capability to support sub-millisecond latencies over the radio interface, and it's been shown in simulations that you can do this with 6/9 reliability, and going down even to a half a millisecond if you give up 1/9 in the reliability. And of course, this is only about the radio interface. So depending on how you then deploy your system, the latencies in the core network can be very low. And so overall, you do get to end-to-end latencies of 1 to 2 milliseconds with 5/9. Another aspect, also very important for the industrial vertical, is this synchronization. So 5G supports synchronization to basically any general clock you want to apply on sub-microsecond level. Moving ahead, so this is still about what is the 5G system like. So one important aspect obviously is security, and with the security we come to things like SIM cards, to talk in general terms. So, and the question may be, do I need to use SIM cards with 5G? The answer is that you may need to use them if you're with this operator provided scenario, You may use them also in your standalone private network if you choose. However, this is not mandatory, so other authentication scenarios can also be applied. And the basic thing is that 5G, like the previous generation cellular systems, they rely on solid foundation of mutual authentication. So both the network is authenticated as well as the device. So this is the foundation of it all. And of course, the integration to the factory security solution is then in the center of this, because we come from a little bit different domains. Now, just to point out, maybe not so much about the set of features, but about the way how 5G comes out. So or how 3GPP systems come out. So 3GPP standards, obviously they define the functionality, but 3GPP standards also define which features need to be conformance tested. And then we have specialist organizations that then can be utilized to do those conformance testing, because any system is only as reliable as its weakest component, so to say, and the certification is one way to assure that you're really getting what you are supposed to be getting. Now, moving on to the exposure. So this is, I believe I said it earlier, exposure is about how the 5G system offers its services to the layers above, or to the applications that use the 5G system. So that's what's behind this term of exposure. So this exposure, we have exposure reference points, so interfaces in the 5G architecture. Basically, we're talking about APIs, and these are used to manage the connectivity that 5G provides. So 5G, it's a wireless system. It's not like a set of wires that you manually connect and they remain there. It's dynamic. You can set up communication streams, and you can modify the quality of service of these streams, and you can remove them. And the exposure interfaces are a way to doing that. And the other aspect that the exposure interfaces offer is the capability for industrial applications, say your master applications, to monitor the health of the 5G network, because you obviously want to know that you are getting the level of communication that you are supposed to be getting. You want to know whether the connectivity to your devices is alive or not. So, and the exposure capabilities, they are available both on the network side as well as on the device side, and accessing these is, like I said, via APIs with IP connectivity, and there is obviously authentication to doing this, so that unauthorized usage can be prevented. Now, when we come to the sort of internal management of the 5G system, say setting up new base stations or radio access points, and configuring which radio frequencies they use, etc., etc. This is handled by the Network Operations Center, this 5G NOC, and it's not necessary for the industrial application to worry about those things. However, the NOC may provide or expose application programming interfaces for accessing some of that information, for example, for this monitoring purposes. Now, moving ahead a little bit deeper into the integration with the industrial communication networks. This is based on a white paper we did earlier about industrial Ethernet, and there is one sort of hierarchical layout of of an industrial communication set here on the left. And with the red arrows, we're highlighting here some of the kind of industrial topologies or the communication capabilities that would be required. So device to compute, controller to compute, controller to controller, device to controller. I think these are very familiar to you OT folks, and we saw these in the Opc Ua presentation as well. So obviously all of this can be supported. Now this figure also features the node called UPF. So that would be the node inside the fixed part of the 5G system in the core network of 5G, as we say, which from where that's kind of the network end of the communication point, whereas the devices then are on the radio end. And the point here is that these various topologies can be supported, and your setup may or may not resemble this one, but it's all configurable, and the communication that 5G provides, it can be set up to support the specific requirements in each of these types of communication streams, because the way we see it from the 5G perspective is that these different communication types, they require different quality of service, and as said, this can be then controlled in the 5G via the exposure interfaces. And well, that's the basic way how it operates. Now, I think this is my last slide, and we come to the, let me say, crown jewel of the support 5G has for industrial communication, and it is about time-sensitive communication in general terms, and in specific, this time-sensitive networking. So 5G in release 16 onwards, so a standard that was published already a year ago, a little over a year ago, supports the IEEE defined time-sensitive networking features in one particular model, and the model we're supporting is the centralized TSN configuration model. So I think this is the .1Q version of the standard. And the way this is specified in 3GPP is that the 5G system is viewed as a logical TSN bridge from other TSN networks perspective. There is a lot of internal 5G system detail here in this figure. Please don't mind that. Let me just put it this way, that the 5G system is seen as a logical bridge where you have one or more ports on the network side, or I think more like one port on the network side. Then each of the UE that is configured to belong to this TSN bridge is another port so there is a number of ports on the device side. So this is the basic kind of logical configuration by which it works. And yeah, let me leave it to that. And as said, this was the last slide. So back to you, Afif.
Thank you, Ati, very much for the very interesting overview presentation about the 5G architecture. And as you said, it takes basically, I mean, weeks, isn't it? You have done it in less than 20 minutes. So thanks a lot. Now we have heard, I mean, both from Opc Foundation, 5G ACIA, from Opc basically Foundation about the unified architecture framework and how it was extended to the field level. In particular, you know, the support of use cases such, you know, C2C, control to controller, and as well the integration, I mean, of communication, whatever wired and wireless. But of course, we still don't know, I mean, how the interaction would be for 5G and if there is anything need to be taken into account. So hopefully, I mean, the next speaker, Dr. Shuli Ann, will be able to let us know, I mean, if there any direct relation or impact, I mean, between Opc Ua and 5G. Shuli Ann, she's the 5G ACIA Working Group 1 Vice Chair, and she's from Huawei. She's based in Munich, and congratulations. Basically, this is Shulian is she's the only basically a woman with us today. Especially tomorrow, it's isn't it the Woman Day for the engineers, basically Woman Day.
Okay, thank you. So thanks for the AFIP's introduction, and it's my great pleasure to share with you some thoughts from 5G ACIA perspective on how Opc Ua could work together with 5G. So for this talk, I will do together with my colleague Alexander Ziegler. So yeah, let's begin. Within 5G ACIA, especially Working Group 1, we spend a lot of effort to discuss about the use cases and the requirements. So on the left figure you saw on this slide, so this is actually one of our first white paper published from 5G ACIA. Back then, we already begin our work to collect all these industrial automation use cases which are relevant to 5G. And then also we try to map it and position it according to this famous triangle shape defined by ICT domains. Then within 5G ACIA, we work a lot about these use cases on this control to control and also motion control type of use cases. Oh, let me put this. Okay, I think now maybe my screen looks better.
Yes, now we see better your screen, Shuli.
Okay, so we work a lot about these use cases with especially high demand on the communication system performance. And then on one side, we try to collect these use cases from the current existing plans. It means like all these use cases are utilized in daily life and in the daily production. So when 5G is ready, these would be the use cases that actually we can utilize 5G right away and then enjoy the advantage of this mobility and flexibility brought in by the mobile communication technology. But on the other side, we also look into the future use cases, meaning like maybe you don't really see these use cases in daily productions, but due to 5G and due to the innovation brought in by 5G, then we could imagine like these use cases may appear in near future. And when we talk about the use cases, there are always two key questions we want to ask. The first one is what? It means like which kind of requirements the use case will bring in. And the second is how. It's like, it means like how the 5G communication system could satisfy this requirement. So therefore, we come to this three-dimension model. So this is actually the way we try to clarify and discuss the requirement. On the fundamental level, so this is what we call the performance requirement. So you also hear it as, for example, key performance indicator. So it indicates like what is the, for example, the communication service availability you need and what would be the latency and what are the data rate and so on. So this is really the fundamental requirement that you could bring in by the new use cases, and then you need to consider to satisfy these use cases by the communication system. And on top of it, we also have a functional and operational requirement. So for this functional requirement, I think some of them already tackled by Ati in the previous talk. Like you may want to have this non-public operation, you may want to have industrial grade security, or you want to have this kind of localization capabilities and so on. So all these are the type of like functional requirements. And then on top, you may also have this operational requirement. So for example, you want to have high flexibility for the operation, and then you want to have a guaranteed 24/7 operation, and then you want to have integrate this communication system seamlessly with your network infrastructure, and you can monitor the performance and so on. So these three dimensions actually gave a very good classification of different type of requirements. Within 5G ACIA, we also work a bit on this service level agreement and specification. So this is also one very important aspect when we talk about integration with industrial domain and 5G. So this means like with the specific use cases, then we try to collect all this requirement, then we could put them in the format of contract. This contract should be agreed between the service provider and the service customers. And for this kind of a service level agreement, or sometimes it's called a service level specification, so it means like the technical component of this SLA, they are not only a type of parameters written down on the contract, so they will be also utilized in the whole operation of the industrial applications. So for example, you can utilize this SLA and SLS for the negotiation of the requirements and then try to reach the expectation. And then you can also utilize them for the testing, monitoring, or policy enforcement in the later stage. Then we put all these practice into Opc Ua and 5G integration. So this is quite a new topic. There are a lot of aspects we need to consider. But based on what we have been working on in 5G ACIA, we gave the following recommendations in terms of the key aspects for consideration. So the first one is about architecture. So it means like when you have the two different systems, that you need to understand like what would be the relevant network functions you need, what would be the information model, what would be the procedures. So these are very important architecture aspects. Then on top of this, then you need to have this queues mapping, and you need to have this queues map. Sorry, you need to have this queues mapping and transport mapping. So maybe some part of my screen is still in gray. Let me just adjust a bit. Okay, hope now it's better. Then for this is an important aspect because you want to guarantee the requirement actually coming from the industrial domain. Then based on this, the important aspect is the use case analysis. Because we discussed a lot about the different type of use cases, then we need to put it in practice. So for example, we could foresee like if we take the use cases presented by Peter, this kind of a control-to-control type of applications, then we need to really examine this queues mapping and the transport mapping based on procedures. And upon this kind of analysis, then we come to the stage, we may be identifying some gaps. So in order to handle these gaps, of course, like we need to encourage the 5G ACIA partners as well as the Opc Ua colleagues to bring these gaps back to 3GPP and bring back to the Opc Foundation to have a further discussion, and then in order to define the specific specifications in order to handle the gaps. Okay, now we try to zoom in a little bit because we talk a lot about these methodologies. Then we want to put it in practice. So on one hand, we have this industrial IoT, which is based on the Opc Ua applications. And then on the other side, we have the 5G system. In order to integrate them together, what we see is like the important part is we need to ensure the application traffic coming from the industrial domain will be handled properly in the 5G domain. So within Opc Ua domains, the traffic model is based on two types. The one is the client server type, and then the other one is what they call the publish and subscribe PubSub type. So basically, this kind of like layer 3 and a layer 2 type of traffic. So then the overall goal is we want to ensure the traffic coming from the Opc Ua domain could be handled properly by the 5G system. And in order to do so, the important work for this integration is at the control and the management layer. So it means like you need to have this two systems have a method to communicate with each other in order to understand the requirement and understand the expectations. Currently, I think there are many work has been done in two domains separately. So in 3GPP and Opc Foundation, there are many network functions has been defined in order to expose informations and then in order to cooperate with the other system. But in order to make sure this two systems work seamlessly, then we need to see what would be the feasibilities. So for example, we could utilize like the what we call 3GPP native interface. So then to examine like what would be the possibility could provided by 3GPP. Then in this case, then for this for Opc Ua, they need to have this kind of like network functions which could possible to translate this kind of interface to Opc Ua protocol and the data model. But then on the other side, you could also have Opc Foundation and 3GPP working together to define this set of interface. Okay, so this is only some early thought. And then as the next step, I will give the floor to my colleague, Alexander. So he will also share some view from Opc Foundation perspective.
So thank you, Julie. And yeah, let me continue. We're talking now about the integration aspects of OPC with 5G, and I want to look at the the requirements of that, and about the looking at the building blocks we see in that area. So you remember that figure? I showed it before. And remember these guaranteed bandwidth and bounded latency requirements we had for time-critical safety messages in our use case. And currently in OPC, we are integrating QoS aspects into our information model and in our network stack to be able to provide deterministic communication for OPC application in general. So this is a basic new part in the Opc Ua layered architecture. And we will use that for several applications. Safety, as you can see, for C2C, C2D, and so on in future. And the idea is to use these general QoS requirements to give the user the ability to define its service level requirements, which then will be used by the network to provide the right network service underneath. And that, can you switch to the next slide, please? Yes, and you can see that these requirements then can be used in different network areas over and over again without changing them. So that's the idea, to reuse your application independently where you put your application, whether you have it on a wired system. For example, inside this mobile robot, you have your wired network, which then is connected via a 5G router to a 5G system, and then the traffic goes along industrial LAN on the right side, or even back into a WLAN system. But at the end, we want to have this end-to-end connectivity, which provides determinism. And for that, yeah, thank you. And we see different means for that. So the building blocks to provide that in the lower system are, for example, in the wired area, of course, are TSN streams. In a 5G system, the pink block here, you can see a 5G QoS flow, a certain PDU session, which can provide you layer 3 or layer 2 connectivity. And this then goes over to a TSN stream and again, and so on. But to build this end-to-end connectivity, we need some kind of umbrella technology, which puts these 3 pipes together to one a single pipe. And we understand that DetNet from the IETF is the way to go here, because it provides the same as for TSN streams for layer 3 networks. Yeah, please go ahead. Yeah, we have seen that before, that a 5G system also could provide a real, a pure TSN connectivity as well. So this logical TSN bridge we have seen before. This is also possible if you do not want to have layer 3 connectivity, you are happy with layer 2 only, or if you need to really tweak the last bit of your jitter and latency, then this might be an approach. But that doesn't mean that 5G without TSN doesn't provide determinism. I think a good starting point is to use 5G as it is right now with its bandwidth guarantees and latency guarantees in its native way. And if you need more, then use that logical TSN bridge. Please go ahead. Okay, and putting all these building blocks together, we end up in this layered stack architecture. In the top layer, you see the parts of the Opc Ua, the blue and yellow boxes, show them. The blue boxes are the base technology elements, such as client-server communication or publish-subscribe communication, and we added, as mentioned before, these QoS requirements into our model. And these requirements then can be mapped on different network mechanisms. You can see in the green boxes or the pink box below. Of course, we have wired systems connected to our 5G, to our OPC stack already since years. That's nothing new, but now we adding a TSN aspects to it. There are certain profiles. A certain profile, the 6802 TSN industrial automation profile, which gives us a list of TSN features to be used in combination for industrial automation networks. And of course, for 5G, we also see the possibility to map them, because 5G provides layer 3 connectivity or even pure layer 2 connectivity. This should be possible to integrate easily. And in future, already now, but in future, Wi-Fi 6 and 7 will provide deterministic communication over Wi-Fi technology as well. So this is something we see on the horizon as well. And with all these mappings, we have a good toolbox to provide different ways how to connect your application to several network technologies. Yeah, please go ahead. Let me have a short look on some issues we see especially in the shop floor area, where we have different areas of responsibility. So we have the machine builder domain, we have the guy who is responsible for the industrial campus network, and maybe there's some data center in your facility. And all these guys need to make sure that your stream or your flows going from the shop floor to the cloud will be established to your needs. And we think that it's important to have these different domains to cooperate as smooth as possible. And for that, not only connectivity protocols are important to make sure these two OPC applications see each other, but also the signaling of QoS is important. So each network part needs to know what to do, what data flows need to be reserved on the several area. So I emphasize that the work in the DetNet group of IETF is really crucial to give such scenarios a good success. Okay, next slide, please. Okay, let me sum up regarding the 5G integration aspects. So we see that 5G ACIA will make sure that the interest of the industrial domain will be considered in the 3GPP standardization activities. So it's good to have them here and to work with us together. And we see that the Opc Ua framework will provide enough flexibility to integrate those technologies, and it will give us more opportunities regarding mobile applications. And Opc Foundation sees 5G TSN and the 6802 as the key elements. So many of the OPC people are involved in standardization of those topics. And we see that the integration of Opc UAFX with 5G is a challenge, but it should be as smooth as possible. So by keeping our clear layering and make sure that the interfaces are clearly defined. And the next steps we expect here in the cooperation with 5G ACIA is to work on those use cases, as mentioned by Julie before, on the architecture, on the QS mapping, and finally an application orchestration mechanism to make that system be handled easily. So, thank you.
Thank you, Alexander and Julianne, for this presentation about the integration basically with Opc with 5G. And as you have also mentioned, the QoS aspect, which is important. So now let's move on, I mean, to the last part of our web seminar. We will have a live demo, and this will be from Frankfurt, where, I mean, Peter, that you have listened to at the beginning. In addition, he will be joined by Joseph Eichinger, who is a 5G ACIA board members from Huawei and based in Munich.
Hello and welcome to our live presentation here in Frankfurt. So we are actually excited not only to tell you how this works in principle, but really having a live demonstration that we actually showed the first time for the public 2 weeks ago at Hanover Fair. And so we set up this again here in Frankfurt and explain you now what we are showing here, and also talk about the use cases that we have integrated in this demonstrator. Now, let me start first of all talking a little bit about how the overall setup looks like with the hardware and the different components that we have integrated. So you see here the big wall with overall 16 different controllers from different manufacturers. It includes all the big brands in automation. And we have different types of controllers. So there are PLCs, there are motion controllers, we have robot controllers as well, and the distributed control system, DCS systems that we find in the process industry. They all support Opc Ua, and they are all connected to a common network infrastructure that you see here in the middle section. So we are using Ethernet switches, we are using Ethernet TSN switches, and we decided, actually end of last year, I suppose it was, that it would be certainly exciting also to integrate a 5G system into this demonstrator. Now, we have been looking at a specific use case or application for this demonstrator. It's a bottling line, which is consisting of different machine elements. So we have machine parts that do the washing of a bottle. We have an element that is doing the filling up, one that is doing the capping, and one that is finally doing the labeling. But certainly this is just one reference application we do. There is a broad range of applications out of robotics in process industry. So really just think of it as an example. Now, I think we can move over to explain a little bit more with the dashboard what kind of use cases we now can show with this demonstrator. So this brings me to the dashboard. You see here on the big screen. Here we first of all have the use case with monitoring or remote monitoring, because here we are actually doing live monitoring of all the 16 controllers. You see for every controller here a tile. If it has a green frame, it means everything is fine. The connection is activated. And this is true for the Opc Ua connections, which is client server based. But it's also for those controllers that already support the UAFX extensions for controller to controller, also showing the status of the other connection type, which is UAFX. It's based on PubSub, which makes, let's say, a more efficient exchange of data possible, especially important if you exchange process data between controllers. Now you see for all these controllers the status, you see certainly manufacturer name, product name. This is not so exciting. It's just static information. But what is interesting is that we can certainly for each of these controllers then have a look at the asset information these controllers provide. So just selecting maybe one of the controllers, you then see what information is exposed by this controller. And this certainly can be read out by any kind of local or remote tool. And it helps also in the diagnosis. It's used for asset management. This is, so to say, the second use case, still using the client server, let's say, exchange mechanisms. Now, what is actually the really exciting new use case is what we are doing now with the extensions for field exchange, because this brings us in the controller to controller use case that we were talking about in our presentations. And this is where we now switch over to what we call the production lines. So you see here the four elements of the production line with the washing, filling, capping, and labeling. And you see that we have been setting up two production lines with just a random configuration, having here Omron, Festo, B&R, Schneider that produce the bottles, and we have the second production line, just as an example, Beckhoff, Vago, Rexroth, Unified Automation. Now, how are you setting up such production lines? It's important to mention that we are using a specific tool which we call the connection manager. It can be either integrated in the controller, like Siemens has been doing this for the demonstrator, but you also can use an external connection manager, which is just a software tool. And you see here a connection manager provided by Unified Automation, one of the supporters of the demo, where we can here set up the production lines with a certain configurations and then visualize this here in real time on the dashboard. So the interesting thing about these production lines is that now these controllers can really exchange process data. It can be real-time data, safety critical data, as we have heard with Opc Ua safety, cyclic data, also acyclic data. So this is completely flexible, and it's a universal standardized interface, which is really supported by all the manufacturers, all the big brands behind. That makes it really unique and takes us away from the rather heterogeneous field bus and real-time Ethernet technologies that we had in the past. But still, it means every controller can have certainly a specific field bus for the devices. But this is then the second project phase we now start when we go down for the controller to device as well. Now, maybe going back to the dashboard where we see all the controllers, this is maybe now a good time to talk quickly about the 5G integration that we have been doing, because certainly we said even this is all wired, and this is also where I come from. All the communication in the applications I was doing in the past was based on wires, but certainly it doesn't matter here actually how these controllers are connected. So we thought about integrating 5G so we can have controllers either connected wired or wireless. And this is now, I think, the trigger to hand over to Joseph. So Joseph will explain a little bit more what we have been exactly doing, how this is working. And I can assure you that it's really working live. So we really have a real controller connected over 5G. And as you see, they're still all green and active and connected. So Joseph, please.
Thank you very much, Peter, for this great explanation of the Opc Ua use cases and the setup here. And I just want to keep you in mind that this green arrows here, the green boxes are really important to show that the integrated 5G network is working, and we have switched it on in the morning, and we have not observed any packet error at the time now, and I'm quite sure we will have a error-free connectivity here for the whole day at least. Yeah, what we have here is, as I said, a fully integrated 5G network. What is here all in the box, all of the necessary components are integrated here in this rack. Before I go into some more details, I just want to spend a couple of minutes to talk about different frequency band what we have in the 5G, mainly targeting also the industrial use cases. Everybody knows this not magic, but the well-known and famous C band that is somehow in this 3.4 to 3.8 gigahertz band, at least in many countries. And this is a primary band for the current usage of 5G in industrial environments. And all of the control-to-control use case, what we have here on the demo wall, could also run with the C band, with this existing commercial solutions, what you can buy right now from the vendors. So C band has one limitation, and that is available bandwidth of 100 megahertz only. And what we want to demonstrate here is with the prototype, what we have built, that we can also use the millimeter wave frequency band that offers a much higher bandwidth, up to 800 megahertz at the end. And what we now did is here we have connected the baseband unit to, on one side, to the industrial controller. For instance, here's a Bosch Rexroad controller, and you see everything is here is green. That means the connection is error-free. And on the other side, on the RF side, we have connected it to the RF antennas, what you see here on the top of the demo wall. These are millimeter wave antennas capable to cover a quite big area in your factory. It could be a 10 by 50 meter area or even larger with enough capacity and radio. And for some reasons, maybe you need more if you want to extend your use case scenarios and if you want to go more ahead with deployment of 5G in your factory environment. As this is what we have here. It's live running. It's already, you could hear it if you are here on site because all of the machineries, they have some noise, at least from the computing point of view. This is what we have here in the setup. Now let's talk a bit more about the KPIs and the technical insights. And for this, we have prepared on the demo wall a kind of screen, a GUI. And this is part of the demo wall. You can see it. It's part of the network here. And it demonstrates what we are currently doing in the network. We have a system that operates in 26 gigahertz. That means in the millimeter wave range with a 200 megahertz bandwidth. For sure, it could go up to 800, but for this, we only need this 200. We see here in this display that we have a latency that is quite low. For the control-to-control application, it's not necessary to talk about 1 millisecond. It could be also maybe 5 milliseconds or 3 milliseconds. That's fully enough for these applications. But actually, we want to demonstrate the ultra-low latency and reliable communication because this is a key for the integration of 5G with Opc Ua, as Peter and others have already shown today in the slides. And this is mainly what we have set up here, and the demonstration is working fine. It was also working so many days in the Hannover Fair without any issues. That means we are quite happy with this integrated demo with Opc Ua and our 5G system. And thanks to the Opc Foundation, to Peter, that we could make it happen and that we could really integrate this. And I'm looking forward to do more if we go from control to device aspects and with all of the new things what we want to develop together.
Yeah, thank you for your support, Joseph.
Yeah.
Okay, fantastic. Thanks to both of you, Peter and Joseph, for this live demo from Frankfurt. I mean, showing basically 5G supporting Opc Ua. And let us now move on to the last part of this webinar. We are a few minutes ahead of time, even more, basically, because you were very quick in your demo. and we will open the floor of Q&A. And I'm looking, basically, I cannot see any posted questions yet. So if you have not, I mean, it's not too late. Feel free, basically, to post them in the Q&A box. And I want to make sure, Peter, Ate, and Joseph, are you with us? Okay, I can see already Peter and Joseph, basically. Perfect, you are with us. And Ate, I believe you are also with us, isn't it? Okay, fantastic. Ate turned his camera. Okay, let me start. I mean, who should be the first, basically, victim? I mean, let me start maybe with you, basically, Ate. And if I want to ask you, I mean, does you have shown the 5G architecture, and does 5G include some specific capabilities to support OPC unified architecture? And if it does, what are those, I mean, capabilities?
Yeah, thanks, Afif. Yeah, that's a good question. And it's a question that we kind of get from many verticals, that does 5G support the thing that I need in my vertical? And the answer is that, well, 5G supports the requirements from the verticals, but the way 5G standards are done, that is that they are more or less generalized into the 5G standards. Maybe TSN is a little bit specific, because it's so specific. You will find very specific features and functions that really name that this is for TSN. But even for TSN, there is a more generic capability introduced to the standards called TSC, so time-sensitive communication, kind of taking the viewpoint that there may be other time-sensitive communication technologies that, besides TSN, that wouldn't require 5G to support these capabilities. So the point that I'm trying to make is that if you go through the thousands of pages of 3GPP standards, and you're trying to look for something that says Opc Ua, and thinking that, okay, now this explains how Opc Ua is supported, you will be disappointed. So the way it works is that there are these generic requirements coming from the industrial vertical, some of it sort of very well represented by the Opc Ua requirements to 5G, and these are then specified in 5G standards, and the support is there. So, but still, there are very specific things that come from industrial vertical, and TSN is probably the key thing for the UA part of OPC. However, I would also like to emphasize, as was mentioned by Alexander, that Opc Ua does not require TSN for all use cases, nor does the industrial vertical as a whole require TSN for all use cases. That's sort of like the tip of the iceberg, and in fact, we haven't even seen that in the products yet. Hopefully, we will get them next year. Let's see. There are many capabilities already in 5G that support Opc Ua. There is no reason to wait. You can go ahead and start to apply, and we're seeing this in the marketplace already. So I hope that answers the question. Okay.
Yes, thank you, Ate. There is also a follow-up question, but I will spare it, basically maybe for 5 to 10 minutes, and I will get back to you on TSN, basically how the standard is progressing and how this is fed in 3GPP. So stay tuned. Now I would like basically to move on, I mean, to our two other colleagues in Frankfurt. They have been waiting patiently. And I would like to turn with you. Maybe I turn, I mean, either to you, Peter, or to Joseph. You decide who would like to answer these questions. Joseph, you have shown basically, I mean, mentioned 1 milliseconds capability, and you said, okay, but maybe other use cases that they do not require 1 milliseconds, maybe even, you know, higher than that. Can you more exemplify, I mean, which are the use cases do you think require basically 1 milliseconds, and if it's really crucial for the usage of OPC protocols with 5G?
Yeah, as I explained already a bit, or tried to explain it, that so we are always talking about this 1 millisecond, but it's a kind of, let's say, peak of the iceberg, what also Ate has mentioned with TSN. But for most of the applications, what we have is in the industrial environment, and also in OPC UA. And mainly if we talk about control to control applications, not just control to device applications. Let's say we have control to control. For this, we don't need really, in almost all cases, 1 millisecond. It's enough if you have 3, 4, 5, and maybe Peter can also give a comment on this one, or maybe even 10 in some cases. If you want to go to control to device applications, then we need maybe a bit lower latency, but I'm not quite sure whether from business point of view, some millisecond is always necessary. Maybe there are always use cases and ideas working better with 1 millisecond, but maybe it's not the most important thing. What we need to think about is what is the business benefit for the factory owners for this kind of business if we deploy 5G, and then we have clearly find out what is necessary, which kind of capability is necessary to run the business. And I don't want to have that we're only looking to the 1 millisecond, because this will stop us.
Maybe I'm adding a little input from OPC side on that. Certainly, as you have seen, we have such a broad range of applications and use cases. So you cannot just say the 1 millisecond is a must to adopt the technology and to make it a success. We talk about applications in process industry that require, let's say, quite low latencies. We talk about applications in factory automation that require certainly shorter cycles, shorter latency times. But as Joseph mentioned, for the controller to controller, we can be relaxed. Typically, it's a range from 2, 4, maybe to 10 milliseconds. And then really, if we go for the additional use cases you have seen, motion control, distributed IOs, real-time IOs, then we certainly come in some areas where you might even need sub-millisecond, certainly depending on how you separate the functionality between the decentralized field devices and the centralized device, the controller. But we then also talk about the precision and the jitter, and we need that sub-microsecond accuracy if we talk about synchronized motion control applications. So also here we have a huge range of requirements and use cases. And if you talk about the iceberg, the high performance motion control is also that iceberg that we certainly want to cover with Opc Ua and the extensions for field exchange, with wired, with wireless connectivity. But it's also in our roadmap just coming up, and it's not the priority at the moment. So we just concluded our first spec, which is about the controller to controller use case with the focus on that. But we start now, end of July, in going that controller to device. But it will take some time. And hearing that also 5G is coming up with additional releases, giving even more, let's say, features, supporting more features. This is running, let's say, in parallel. We are not blocking each other. We are complementing each other, and every technology is further enhanced and becoming additional features, which is certainly needed.
Yeah, thank you, Peter. You mentioned control to control and then control to devices. Of course, this is maybe still maybe theoretical, I would say, and I think there is also interest. One, this is coming basically in the market, and you don't have to answer the question right now. I just want you to get prepared. So from the business aspect, one, those are coming. Is it basically tomorrow? Is it next year? People I think, are impatiently now waiting when we see at the Hanover Fair. But before you answer that, I would like to go back to TSN. We received the question in the chat about TSN, and that I hope Ate is now prepared to answer it. TSN, time sensitive networking, that standard is progressing. It's from IEEE and IEC as well, and this is they continue to work on it. Release 16 and 17 to support the main features. But how will be this? What is coming next? Is there what is for release 18? What do you expect, and how this will be fed in 3GPP future releases?
All right, thanks, Afif, and Alexander in chat for the question. Yeah, as said, the support for TSN has been there in the 5G standard since release 16, and so it's been available for over a year. And what's supported there is the centralized configuration model of TSN, which was, at the time when the development for that started, the kind of main focus of the IEEE TSN work, and there have been discussions about other management and configuration models, like the distributed configuration model, but and there is the discussion about the profile, the 6802, that defines what's the main TSN features in the industrial domain. So those were not available at the time when the release 16 TSN was done for 5G standard. However, from 5G perspective, I think the situation is such that the community is waiting to see what is happening in the TSN domain in the field. I mean, this is a technology used mainly in the industrial vertical and also in the audiovisual vertical, and we need to see first how these are utilized in the verticals before we go into new development in 3GPP for 5G standards. So there hasn't been any substantial addition to the TSN capabilities in the 5G standard. And sort of this is aligning with the discussion we had earlier, that it's kind of the tip of the iceberg. There is so much more that is important. There is so much more that is already available in the products. People are putting them into use. We're seeing 5G being taken up and being used in factories for all those other use cases that do not require the 1 millisecond latency and determinism that TSN provides. So the sort of focus has been on that, and let's get the ball moving, and let's see where we go, and then we can start to address new things about TSN in the standards. And as it comes to integration and working together with OPC, I think the discussion is right there, like how do the capabilities provided by 5G and exposed to upper layers can be used by the Opc Ua on the upper layer. We need to assure that this interaction is flawless, and these are the points that Sue Lee was making in her presentation, and we're continuing that work and finding out that there are no gaps, that it actually does function seamlessly. There is no reason it wouldn't.
Yeah, thank you, Ate, and it makes sense what you have said. The main basically features of TSN are there in 5G, so let's see when the market will pick up and if there is a need basically to complement with additional features in the future. And I will turn back now to you, Peter. I mean, I mean, this basically boiling, I would say, question, which is difficult always to answer, one things will be happen in reality, from the business aspects, which, of the use cases do you think will be dominant in the near future or on basically on the long term as well?
Yeah, so it's a difficult question because certainly I can mainly speak for, let's say, the progress of specifications. This is what we do in OPC, also providing a testing program certification, but certainly about the roadmaps of the suppliers. It's difficult to speak from our side, but maybe the best answer I can give on your question is when we have in mind the graphic that Alexander was actually showing with the different mappings. I mean, we can already today use existing products supporting OPC UA that are even certified by OPC using TCP/IP, UDP/IP, and there is no reason why you're not using such controllers over Ethernet infrastructure, over a 5G infrastructure. So this is possible today. So it's not, we need to wait until something is finalized. Now, as we discussed before, if we now look into some more demanding, let's say, mappings, which is in our case, the direct layer 2 mapping, in order to make the communication more efficient, to save bandwidth and to reduce the cycle times, then this is also simple if you just make use of an Ethernet infrastructure and use priorities with the frames. So this is also something that can be done today, and the products are partly already supporting this direct layer 2 mapping. And now the story goes on. If you then want to more optimize and use devices in more demanding applications, then TSN comes into play. And this is then something, as we have heard, we need to wait. Even TSN is available today. We have also chips for TSN available. We are still waiting on this famous IEC IEEE 6802 TSN profile, because only after this is, let's say, released and agreed on, we really have a stable common basis on how to use the TSN features out of that toolbox of TSN. And this is then more, let's say, midterm. It will still take some time. Even we also not waiting until this is released. So we do an educated guess. We work towards that, because if you work fully sequential, it would take another 10, 15 years. And this is not what we have in mind. So we go step by step. Products available today, no good reason why not already running communication over 5G today. And then if it goes to more demanding applications, you certainly have to ask the manufacturers what they support. And we for sure have to wait on some progress with regard to technology and then adoption by the vendors. Hopefully this is a good answer to your question.
Yes, yeah, thanks. Thanks, Peter, for the extensive answer. You mentioned actually while you were basically answering the question about, the maturity of the business use cases for the years to come, about, that you deal with certification as well, And so I was wondering, I mean, if 5G basically is, let's say, becomes part of OPC UA, does it imply, what does it imply from the certification aspects? And why I'm asking as well this question, because in 5G ACIA, we have been looking at the certification framework, and if there is any impact we should look at basically from both basically the network, the devices, etc., that we should take into account. So this is work is currently conducted within 5G ACIA. We have reached out other basically forum like GSF, GCF, etc., to see if, you know, what do we need to take into account. And that now it's important I turn to you, basically ask you, is there anything that we need to take into account? Maybe you don't know exactly how the certification of 5G is being done, but from Opc Ua basically perspective, is there any impact from 5G on your certification aspects?
Let me start with the famous "it depends." It depends because it certainly depends on the product and how it is, let's say, supporting then 5G in combination with Opc Ua. So we are providing a certification program and test software that can be used by the suppliers to prepare for the certification that mainly does, let's say, a black box testing of either a software application or a real device. And certainly we look for the overall behavior, that this is all correct, but we certainly have the focus on Opc Ua, which is layer 5 and above. But we have certainly the protocol stacks as a essential element, and also the physical layer. We are not expecting our labs to do any detailed testing of that, let's say, rather complicated, especially hardware related or physical layer related testing or certification. So we look for the overall behavior and such certifications that are required for wireless connectivity or for Ethernet TSN control or whatever. This is not done by OPC. That's why we need certainly to look together with other organizations how we can help the manufacturers to make it as easy as possible. We already got today or have today concerns from the industry that say, if I need to go to 5-6 different instances for getting certification, this is not acceptable. On the other hand side, we also see it's difficult to realize this famous one-stop certification or one-shop certification. They send the device to one place and then all the certifications are done. That means we are preparing for doing more cooperations on that. Opc Foundation just recently, actually 2 weeks ago, has published together with other organizations the plan to create a common TSN test specification, which is one important element that finally we accept other certifications because they are based on commonly approved test specifications and test software. And this is then helping to get out of that more and more becoming complex implementations, but still having the focus on the technologies we are supporting. And OPC is taking care of OPC, and we are not the specialists on 5G or TSN, for example.
Understood, but this is interesting. And actually, you know, since anyway we have, you know, like a signed agreement between both of us, 5G ACIA and Opc Ua, I think it's important that maybe this aspect we have neglected so far, so we are on the same level. I think this has not been part of the discussion, and maybe we should as well, because we have our activities on that. And if you are also talking with other forums, you know, about certification, we would like also to be on the loop to say so synchronized.
Yep, good point.
Okay, fantastic. We have received a question from the chat as well. I mean, this is, I think, both you, Ate, and Joseph can answer. Is about, you know, how about the spectrum, you know, that most of the, I mean, the 5G spectrum, of course, you have it on the national levels, and certain countries, they have also decided to allocate it on the local level. There are different models we have seen, it depends on Germany or elsewhere. And so the basically the David Tombon, he's wondering, would it be, I mean, that way? I mean, or do we anticipate basically any changes? Is it, I think, either an or? I don't want to answer the question. I leave it to you. I don't know who would like to volunteer to first, because Ati, you showed, I mean, maybe deployment models, and there is also basically a relation to that. Joseph, would you like maybe to start a little bit, and maybe Ati can complement as well?
Yeah, also thanks. Also this different deployment models what Arte has as a rapporteur developed within 5G ACIA in some years ago. That was really a kind of guidance for many future technology developments. And this is for sure a bit connected to the spectrum part. And if you look from a global point of view, there's in most of the countries no local spectrum for local users. In most of the countries, you have a kind of a public spectrum, and you have to ask the owner of this whether you could use it or whether he borrow it or whether he helps you to deploy the network on the spectrum. This is actually what's happened globally. In Germany, and as you said, Afif, in some other countries, we have different other models, and they are helpful in these countries, but you cannot use it as a global model. You have to, as a vendor of 5G equipment, you have to take all of the different spectrum rules into account. That's the first. But before I give it to Arte now as a second things, I just want to highlight one point what came in my mind as we talked about the quality of service. Because 5G has already a lot of quality of service mechanisms in place. They are already, we have a lot of things already implemented, and you can already tune your radio connection in many different ways. And if somebody is more interested in this, we have also a nice tutorial and a nice white paper, and you could have a look to this one. But this is, let's say, needs further developed if you want to connect something with Opc Ua. It's just to say this a bit, because it should not happen that somebody has an opinion that 5G has no quality of service. That's not true. Yeah.
Thank you, Joseph. Ate.
Yeah, sure. So yeah, thanks for the question, David. I think the simple answer to your question is yes, and this is what Joseph was also already explaining. And just maybe to generalize and talk about the topic a little bit more. So 5G standard is a global standard, and we have these different jurisdictions and different situations in different places in the world. It's not the same everywhere. So a level of flexibility was needed. So 5G can operate on licensed spectrum, but it can also operate on unlicensed spectrum. And the most stringent use cases that really require the communication to be deterministic and maybe have very low latencies and so forth, they work best when the spectrum is licensed. So there is a permission for that party, your network, only to use the spectrum, and nobody else can use it. And as has been explained, in most countries, it has been understood that local licenses for local private 5G networks are needed, and way to access that kind of spectrum licenses have been made available. I think Joseph already alluded to the way it's done in Germany, so you can get the license, and it's very flexible. It costs a little bit of money, but it's not. They're not taking your arm and a leg. It's possible to do that. Then there obviously is the national spectrum that the telco operators use, and if they provide the private networking services, then it would be on their spectrum. Just as a reference, let me say that in Finland, where I'm from, they allocated all the spectrum to the telco operators, but they have been mandated to allocate local licenses for industrial operations. So these local private networks with dedicated spectrum, they work that way. So you can get them from the operators.
Great, thanks, thanks, Ate. I think now we have reached the end of the web seminar, because maybe I can say a few closing words. Is there anything else that you would like before we close? Ate, Peter, or Joseph would like to say? And of course, I mean, Ate, there is a white paper on few of the aspects that you have discussed, and Joseph, I mean, we have a white paper, isn't on the SN, we have a white paper on the deployment, basically we have on the requirements, etc., and the QAS, Joseph, what you have mentioned, and SLA as well. So we have many white papers. You can go to our website, of course, and see all these white papers. Okay, so if there are no more questions, I thank you basically, I mean, to be present there. I mean, from Frankfurt, Peter and Joseph, and as well basically Ate from Helsinki. And let me move on basically to the last basically closing few words. And Jackie, if you can, yeah, move on exactly to the next slides maybe. Where, I mean, if you have any more questions, as I said, write to us, basically the info@5gacia.com. We are very happy to answer you. And if you would like, some of you basically are interested as well to join our plenaries. I mean, 5G as a host, we are welcome. We will be, after the summer vacation, we'll be in San Diego and the US. We'll have a workshop as well. We'll be as well at the Hanover Fair US, IMTS in Chicago later in September. So you are as well welcome to visit us and meet us there. Great. So I thank you basically I thanks first, I mean, the speakers and also the 5G ACIA office that have been supporting this workshop. And thanks to all the speakers, Alexander, Ate, Joseph, Peter, Andreas, and Julian. And we hope, of course, we have seminars, web seminars every now and then. So stay tuned and subscribe. Basically, if in case you join your seminars, the seminars, you will, I mean, and you have interest, you will receive basically information about the coming seminars as well. So thanks a lot, and hope to see you soon. Thanks. And of course, I remember, I forget one thing. This afternoon we'll have the same seminar basically, but with also slightly different speakers. It will be live. And this will be dedicated as well, I mean, especially for the people in the US or basically in Americas. Thanks a lot, and see you soon. Goodbye.
Bye.
Bye.
Bye-bye.